Positive aircraft control is a special emphasis area of the FAA, meaning it is deemed a critical phase of flight. The opposite of positive aircraft control is loss of control. Loss of control is the number one killer in general aviation. When an aircraft enters loss of control, it is considered to unintentionally enter uncontrolled flight. This usually happens when an aircraft enters a flight region outside of what it's deemed for, or it's operating outside of its flight envelope. So it has a very aft CG, or you're taking a transport category aircraft and you're trying to do aerobatics with it. The main contributing factors to loss of control are bad aeronautical decision making, bad stall spin recognition and recovery, breaking of federal regulations, bad procedures, inexperienced and not proficient pilots, and the use of substances which have not been approved by the FAA. How do you prevent this? Well, you can prevent it two ways. One is doing a pre-flight, because the most common cause of loss of control is actually an aircraft just coming out of maintenance and having a mechanical failure. So to prevent this, what you should do is do an extra thorough pre-flight, meaning check the aircraft logbook, make sure the aircraft mechanic has signed it off, check to see what work was done on the aircraft so that when you go out to the plane, you can then check that specifically to make sure all the bolts are in, no wires are undone, it looks to be safe, and you can go to fly. Another thing you can do is while in the air is fly the plane. Aviate, navigate, communicate. This means no matter what happens, you fly the plane first, because loss control is when you cannot aviate, you're not flying the plane. You might be able to talk on the radios the best, and you might be able to be the best dead reckoning person out there, or you just follow the GPS. But if you can't fly the plane, you're in trouble. You also want to stay ahead of the aircraft. You should fly the plane, don't let the plane fly you. You got to know where the plane's going to be so you can be ready for that when it's going to happen. Also, what else you should do is that you should be very aware of what's going on. You take your situational awareness to the next level to help you with not losing control of the aircraft. Also, do not get distracted. Passengers are a great thing to bring on the plane, but they're also one of the biggest distractions out there by talking to you, asking you questions, pointing out this, pointing out that during the critical phases of flight. Before flying, you should always brief the passenger on sterile cockpit and remind them that you need to fly the plane first. They're along just for fun, but your responsibility is to fly the airplane. The final thing you should do is be a perfectionist. Always want to improve. Never be satisfied with the level you're at. Always want to make yourself better, whether it's your better stick and rudder skills, more knowledge. Whatever it is, don't just be satisfied with okay, go for great. So today, we're going to be discussing the flight computer, more commonly known as the E6B, and how it is used in our pre-flight and en route plannings. An example would be this flight plan we have, which goes from Allentown, ABE, to Harrisburg, MDT. We have our course of 258 degrees, we have our wind direction, which is 220 degrees, and a wind velocity, which is 30 knots. We have a true airspeed of 105 knots. We also have our distance, which is 67 nautical miles, and we have our fuel burn, which is 6.1 gallons per hour. Using the E6B, we will be able to calculate our wind correction angle, which will give us our true heading. We'll also be able to calculate our ground speed, our estimated time en route, and the fuel that we will burn. The way to use the E6B when planning is you start on the wind side. On the wind side, there's a few main components. You have the wind card, which has the wind speeds, which is designated by these lines, and the correction angle, which are these lines. You also have this rotating disc, which will be used to put on where the winds are coming from, your true course, and another important part of this side is the grommet, which we use for the ground speed. And you can remember the grommet shows the ground speed by the G's go together. So, for our flight plan, it says that we are going to go to Harrisburg heading 258 degrees. To start off to use this, we must also realize that the instructions are put on the top. So it says, instruction number 1, place the wind direction under the true index. So the way to do this is you find our wind direction, which is 220 knots. So we put 220 under the true index, 220 under the true index, and we must now put 30 knots in there. The trick to doing this is instead of doing all the math, you take the grommet and you put it, circle the 100 knots. And then all you have to do is put a dot, the 130. This is because 100 knots plus 30 is 130. Then, instruction number 2 says, mark the wind. We already did that. Place the true course under the index. True course is 258 degrees. So we will now rotate the disk to show 258 degrees. And it says slide the wind velocity mark to the true airspeed. So our true airspeed, 105 knots, we will now take this dot and slide it until the 105, which is going to be denoted by the in between those two arcs, has the dot on it. We will now be able to read our ground speed and know our wind correction angle. Our ground speed, as we can remember, G, grommet, goes to ground speed, shows 80 knots. So we'll go to our flight plan. We will go over to our ground speed, which is here, this box, and we'll put in 80 for 80 knots. We then have our wind correction angle. Remember, our wind correction angle is denoted by these lines here, and it shows that we have 10 degrees of wind correction angle. Now, although it says here you subtract to the left and you add to the right, that might not be the easiest way to remember it. A way to remember it is you lose to the left and you raise to the right. Lose to the left, raise to the right. And that's due to this line right here. If it's on the left of this line, you lose it, so you subtract it. To the right of this line, you raise it, so you add to it. So we have 10 to the left, so we lose it, subtract 10. So we go over to here to our wind correction angle, and we put minus 10. Then to get our true heading equals our true course plus or minus the wind correction angle. So 258 minus 10 is then 248. We now have our true heading as well as our ground speed. That is all we will use this side of the flight computer for. We then flip it over to the other side. On this side, although it looks very complex, it's pretty straightforward. Each of these things has a certain meaning. You can usually find the meaning by looking at the formulas. So, this is what we call our rate index. All of our rates are based off of that. Rates, miles per hour, fuel per hour. So, for our flight plan, we need to know our estimated time en route to get our gallons per hour. So, the way to get our estimated time en route, is we take our rate index, the big triangle, and we put it on our ground speed. Our ground speed is 80. So take ground speed, put it to 80. They're lined up. Then what we do is we look at our instructions here. This outer rim, the A, is our distance. This middle one, or the first ring on the spinning part, is our minutes. And the inner ring on the spinner is our hours. So what we do is we have it lined up with our 80. We find our 67 nautical miles. So here's 70, go 3 back, 1, 2, 3, and we find out we will be going for 50 minutes. So, come over here to our flight plan. We put 50
minutes. Now that we have our time en route, we can get how much fuel we're going to burn. So, we know we burn 6.1 gallons per hour. We come back here, we look at our formula. It says fuel burns on the outside, minutes and hours again. The same as our time and distance, except the outer ring instead of distance is our fuel burned. We take our index indicator, we bring it over to 61 or 6.1, and then we read, and we find our estimated time en route, which is 15 minutes. Come to 50 minutes and find we'll burn 5.1 gallons in our trip, because 50 minutes, read up to the gallons per hour, is 5.1 gallons. So we'll come over to our flight plan, fuel, or how much we're going to burn, and we put in 5.1. And that is a simple rundown on how to use our flight computer.